we we can talk about. I think we made a lot of progress last time, and I'm not sure if you guys look at the summary I sent out last time. You know, the one of the things I made one graphs about how this UDF structure looks like. Let me share my screen a little bit.
Oh, by the way, this is recording, and I will edit the beginning now.
Thanks, Kevin. Sure. Thanks everyone for joining this meeting, UDF meeting. Last time we discussed a lot about how this UDF, the metadata JSON structure looks like. And this is my summary sending out about like 2 weeks ago. And I think it's a bunch of things we figure out. For example, we try to put the overloads each versions, and there's some open questions. For example, um, the properties like deterministic doc property for each overloads, as well as open properties. Where do we put them? Right now, I put this place where each version is going to have a open property. I think it's a little bit controversial last time. In that case, the open property will be versioned. So next time you try to update version, it's going to be another one, and then, for example, V2 or V3. And other than that, we try to have the separates the signature definition, which define the parameters as well as the return type. And I think this another thing we discussed last time is about a doc. For each parameters, we try to put some descriptions for this particular parameter, which is along with the parameter as return type as the one signature. And this signature is very much like the table schema. It will reference by the overloads, each single overloads. For example, this is ID1, then the overload one will point to one particular signature here. That's pretty much what we talking about last time. I didn't get a chance to work on a PR last few weeks. And I think next 2 weeks, I'm going to have more time for that. So I'm trying to work more on this. Is any other kind of open questions, things we want to discuss today? I think this is the structure we overall have a consensus on that. And we of course we can talk about more detail then.
So this might just be a terminology question, but what are we calling an overload?
Overload is a different signature of the function.
So how can, like, I'm looking at this and I've got a signature definition which comes off of the root, but then my overloads are below. And are we saying that the ID is what actually ties them together, not the structure? Okay.
Yeah, it's pretty much like table. You have schema, different like schema ID, schema 0, 1, 2, 3, and then you each like overloads like a snapshot. It's not like 100% good energy, but it's like snapshots. I mean, every time you can refer to one signature.
So the idea, I think, is you might have the same function signature in, different versions. And we don't want to just copy that all the time. You may also want to make changes to those signatures that don't don't create a new signature ID. So if you were to add documentation to one of the parameters, you didn't fundamentally change what the signature is. You just annotated something with a comment. So I think that is a reasonable way that we want this to work. It is a little bit of a departure that we might say that, your documentation on each signature can change without necessarily changing the signature ID, which is a departure from what we do for schema IDs. At the same time, maybe we just relax those constraints for schemas, because I don't think that there's anything in the spec that actually requires you bump the schema ID. It's just something that we do.
Yeah, I can see it going either way. I mean, I guess the question is kind of like, obviously you don't want to have the same signature repeated over and over if you're changing the definition, but it's also a question of like, how frequently do these change? But I'm fine. It wasn't apparent from the structure what that relationship was. So
Yeah, I think especially we discussed about the doc changes potentially for these parameters. We want to put different description or add a description for certain parameters, which we're uh, kind of makes a new version of uh, schema, which is signature here. Uh, then we don't have to change the overloads in that situation.
So I have another question here, which is, why are open properties at the version level? Because any change there would require copying the entire tree underneath that. And I just want to make sure that there are use cases for arbitrary properties that attach to version rather than attaching to the function or the root.
Yeah, I think this is actually a one open question from the last time. Yeah, either we want a versioned property or not a version property. The downside of a version property is every time, just like you said, it's kind of amplify every time we change the version, which is seems duplication and potentially will make the mandate JSON file bloat because just a tiny change
Well,
will copy
we
everything.
can still version properties without necessarily attaching them to a version. So, but really, like, we can come up with more complicated structures. We could say, we have some change number associated with the actual metadata file, like the version number that we have for table metadata files, that is always one up increasing. We could attach properties when they are set to those versions and encode deletes. And that could be an entirely separate structure than the actual versions of the UDFs themselves, right? So we could keep everything basically in line with those versions. I still don't think that there is a great argument for versioning these properties. I think that you're probably trying to do things that either we don't care about or so the properties, for instance, are supposed to control things that are outside the definition of the UDF, right? So we've used these in the past to do things like, how many versions do I keep? Right? What length of history do I keep? I think that that's reasonable, but I would never attach that to a version and say, like, hey, version 10 says I should keep 5 versions, and version 9 says I should keep 10 versions. Which one should I respect? not only that, like what are people doing that require properties to be versioned?
Yeah, that's in that case, we at least need something on this root level. Say, okay, this is a property, for example, the how many version we want to keep, because that's kind of root level property.
And other examples I can think of root level properties are, you know, things like don't allow overloads that don't have a SQL dialect or something like that. Like, I'm thinking properties are a way to change the behavior of the library itself, not the function, or at least that's what we've been using them for. I'm not sure that we need, again, like I'm not sure that there's a use case around versioning those things. And, if there is a use case around it, are those things, should those be actual like properties of the definition itself, like is deterministic?
I think I'm in agreement. The main thing I was thinking about before is kind of a pre-rest catalog concept, because now you can always do auditing of these kind of changes at the catalog level. So if you did want to audit the history of how these properties were set in the UDF, you could rely on the catalog to do that rather than have it baked into the format itself. So now that we have that capability, I don't think it's as important to version everything.
Yeah, I think for deterministic, we decided last time, say, okay, for we're gonna have a explicit key value for deterministic, which is not open open properties.
Yeah.
And put inside or put under the overloads. In that case, the overloads, each individual overloads could have its own, whether it is deterministic or not, as well as the doc.
Yeah, so I don't know about doc, but I would probably not label that box properties because these are really just attributes of an overload. So I'm drawing a distinction between properties and attributes, meaning like attributes are things that we call out with a known key on that object. And properties are sort of this string map of catch-all. Also, do we want doc at the overload level, or should doc describe?
It's already noted up its signature, so I don't know why we would want it at the.
Yeah, why do we have?
Well,
Is
so
that doc a different doc?
there's both the documentation of like how do you call this signature? What does this thing do?
Mhm.
And the doc of each individual parameter itself. So I think that the parameters have docs. But I would also probably move the doc up to the signature because we don't expect that to behave all that differently across signatures, or do we?
I was wondering how we would even have a way to call that, like when you're asking for this, for the doc of your signature, what do you get? Like, I don't know. When I'm getting an object from here to actually put into my engine, am I talking about the details of the specific overload I'm about to use, or I don't know. I feel like it's just simpler if we just keep everything at the signature level.
I think it's better to keep it at the signature level too.
You're talking about just docs, though, right? Not.
Yeah, something that so the example I'm thinking of, because we were just talking about determinism, is like generate random integer, right? And you have a rand function and you say this generates a random integer. You might have an overload of that rand function that takes a seed, and so the seeded one is deterministic, the unseeded one is non-deterministic, and you want some doc at the top level to say like, hey, this is a non-deterministic thing that returns a random number, or if that makes sense. So I think it makes sense to hang the actual function doc, describing what this signature of the function does as a signature.
Yeah, so then I think it also helps to define like, well, what do we put in attributes versus what we put in properties? And attributes are things that I would assume like define the behavior or affect the behavior of how the function operates, and like people building engines around it need to know about those things, as opposed to properties, which we probably want to say should not have impact on the behaviors. What do we plan on storing in properties? Or is that just we have properties on everything else and we're going to keep the bag of stuff?
So I think that's why we want to limit the properties to the root level, and because we don't want people overusing properties. We've seen a lot in table cases that people want to put their own stuff there, and then they want to be able to update it atomically, and like we don't really think that that's a great idea. This is probably a lot less of a risk here. To me, attributes are just things that are attributes of the concept or the object itself. So I would say update at version and signature ID to me are also attributes. They're attributes of what this thing is.
Now we have two attributes. Why did we add the attribute to the overloads level?
So that's just, at the overloads level, we want to know whether this is a secure function. I'm not sure where that actually goes, but again, I don't think we need boxes labeled attributes. I think we need a box that says deterministic. Right? Does that make sense? Like, all of these things are attributes of the object in that they are like, they're part of the
fields
definition.
Yeah, I think you're right, but I'm just doing that for my convenience in case there's money for box.
Then the deterministic is Boolean. Sorry, Daniel.
Yeah, so I was just gonna say that like I'm only concerned about the only having one thing for deterministic, just because we likely will find other things that fall into that category of attributes. Like, is it null safe? Is it does it have some sort of other characteristic that we have to care about when implementing, like memory? Or so I'm just concerned that if we don't have a place for those things, then we're going to have problems in the future.
But then the question is, what level of the tree is it appropriate to place those things? Is it an attribute that defines the object itself, or is it ancillary information as a hint? I don't think that we should add arbitrary properties at each level in order to future-proof for those situations. I would much rather at a later time come back and say, hey, we have another thing that we want to attach to this object.
Yeah, I wasn't arguing for arbitrary attributes at every level. It was, there are a set of things that we know about at that lowest level: determinism, null safety. I don't know if there's other things that we should look at, the Spark and Hive and other function implementations, about what attributes do they expose, because we'll probably need to represent those. Trino, and figure out, does that all fit within that same place of determinism, or is it really there are things at different levels that we have to care about?
I believe it should be under the representations, right? Because let's say that our UDF has the Java, Python, JavaScript versions. Then each of them should have their own sandboxing, and basically Blink do the same thing for Python, just calling the remote call for Python from the Java?
I don't think that deterministic at the minimum should be at the representation level. Representations are required to produce the same result no matter which one you use, or effectively the same result.
There is a box on the representation specific, then the representation 1, 2. I believe under that box we should have some sandbox related attributes.
So at least determinism, all of the representations must be deterministic or not deterministic. They cannot differ in behavior, because what we're saying is these two representations of this function produce the same thing.
So if I,
yeah, sorry.
I'm wondering, what if I'm in a situation, I have an engine that does not have a deterministic random, but it has a random function. Do I just mark the whole thing as undeterministic because I've got one representation that can't be, sorry, I put them all as deterministic. No, I have to put them all as undeterministic because I have one that can't become determined.
So in the case where you have a deterministic random, or sorry, you have two representations, right? One that takes a seed, one that doesn't. And they produce an integer between, say, 0 and 100, right? So you have those two overloads. Within the non-deterministic overload, any representation of that must produce effectively the same thing.
So I'm asking a slightly different one. Say I have random. I don't have it with a seed, but my engine only provides me a way of getting a deterministic random. So I have a representation that is deterministic, but all the rest of them are undetermined.
So what is the difference between representations?
So like, say one is Python code. I'm imagining a special Python where the random is deterministic. The first value is always 1, and the next is 3, whatever. I mean, I'm sure there's some random generator
so you
somewhere.
could do like random with a fixed seed.
Yeah, where just the system itself just always does that because of lack of, I don't know, entropy generation or something. Whereas I have a different representation which uses a well-defined function that always generates a pseudo-random number. Am I allowed to mix those in the same UDF definition, or do I have to have like two
Well, I
different ones?
think, isn't it mostly how an engine needs to handle that function? Like, it's not about necessarily the output. It's like an engine, like what Hive, I only remember from having to do this with Hive, but Hive treats deterministic functions different than non-deterministic. So, when it's actually executing, it has to possibly create a different plan depending on whether it's deterministic or not, right?
Yeah, I think I'm with. So it's not so much as if I don't mark it as deterministic, doesn't mean that it couldn't be deterministic, but it means you can't rely on it being deterministic. So it's not so much like this or something else. This is a property it has if we mark it, and might not have if we don't mark it, but might have. Yeah.
And
okay.
The representations need to provide the same guarantees.
Okay.
Right. We think of them as providing or producing the exact same result no matter how you get there. Now, right, like we can't guarantee that. But that is the intent of the representations, so that if I run the Snowflake representation and the Databricks representation, they effectively produce the same thing. Now, talking about non-deterministic and random stuff really brings in a crazy kind of dimension to it, because you might have...
Part of the issue is we're using random as an example, and usually determinism has an input. And what you're doing is you're deciding whether you can cache the output based on the input, right?
Yeah.
So the random function, seed or not, is not a great example for that, because determinism in a random has more to do with the order in which it's called than what the inputs and outputs are. So
we're not supposed to treat the random ever as deterministic, even if we know it might be.
Yeah, well, because also if it depends on how many times you call that function and in what order and things like
Yeah.
that. That is a terrible example. And in fact, maybe that's an argument against having deterministic even at the overload level. Maybe like there's I think a good chance that this should be at the version level, just like secure.
It probably is not going to matter too much, but like I think because we know that that is a particular one that you have to implement in pretty much every UDF representation, like getting in the right spot does matter. So if we have examples where we can like not random, because that actually is not the deterministic example.
Yeah.
If we have examples that we can point to and say, yeah, or maybe we could go find in like Spark or something an example of one that actually is both.
In Spark,
can,
it's at the bound function level.
Yeah.
So yeah, Spark grabs this from after you've determined the overload.
What's the Spark interface for this? I was trying to look it up in the project.
It is bound function. So unbound function is the function by name, and then bound function is when you've taken a set of parameters and bound to that set of parameters.
I think some engine or some like Postgres use volatilities for random stuff. Like what Dan said, the deterministic is mainly say, okay, if you give an input, every time you give it, generates the same output. But the random is not a good example. Some engine distinguish them by adding another attribute called the volatilities, which is every time you call that function, you get different result.
So there may be more things that we want to do here, but I think that right now, what we have here is a very reasonable starting point. I'm not quite sure about secure. That's the only one that I am wondering, like, is secure a property of the entire UDF? I mean, so are we creating a situation where, okay, so first of all, is secure at the version level in this diagram or at the overload level?
It's in the version level means you can change these UDF to unsecure in next version. I think that's how it works. Otherwise, we put in the top level, which is yeah, you can still change that in that case.
So I guess if I have a command to alter function set secure, and that I run that, does that mean I need to, like, what's the difference between V1, which was not secure, and V2 that is secure? Right? Can I, if I'm not supposed to show the user V2, and it in no way differs from V1 because of how I set the secure property, are we doing the right thing with secure? Or should this be a top level secure attribute that says all definitions of this function should be secure? Because I think with secure in particular, we want to err on the side of marking things more secure than they are, rather than leaking information. So I would say as soon as this thing is marked secure, we don't provide access to any of the versions.
Yeah, what if you change a secure UDF to unsecure? Is that allowed? If that is allowed, then that become an issue, right? Because you are potentially see the old version of that.
So that is up to the engine, right? Like we don't necessarily define how to get from one version to another, but I think we do want to say that if you mark a UDF as secure, all versions of it are secure. at least that makes the most sense to me, because if we didn't do that, then I could see situations in which you define the UDF and then say, oh, I forgot to add the secure keyword. Then you add the secure keyword, but you are still leaking the definition. So I think that we would be creating situations in which it's very easy to leak the definition or, you know, violate the secure property if it's attached to version rather than attached to the UDF itself.
Why it's not attached to signature then?
Because signature is an overload, so that would be going down a level. So we would be saying that this, you know, going to our examples of like RLS or CM functions, right? It would be saying, you know, when I'm looking for a single parameter, it's secure, but when I'm looking for two parameters, it's not. Like, I don't think that that is necessarily a better way of modeling this. I think that either the entire function is secure because we may have things that were incorrectly marked otherwise, or the entire function is you know, not secure in that you can show it and it's just a normal function.
Makes sense to me. We build the trust basically for the user. Everything is secure or not in the first place.
Yes. So I think another thing is because right now we kind of simplify the UDF a little bit. So the a lot of the engine actually they go down to the overload level for all these attributes. Each overload has their own entities, and you can definitely make one overload secure and another overload non-secure by same function name. They are literally different functions, even they have same function name. But I think this design, we try to make that most compatible with multiple engines and to allow, especially allow, we're talking about the potential issue when we allow overloads for engines does not support overloads. They will pick up one of the things to execute, then it becomes an issue. So I think that in that case, we kind of simplify it a bit more, say, okay, we put all overloads in within the one single entity so that they have in general, they have the same security boundary, access control boundary. For example, if a user is the owner of this UDF, then he can update the UDF, add new overloads on us, but you cannot split the ownership for overloads.
Yeah, I think we're in agreement here that just to be cautious, if anything in here is secure, we want the whole thing to be secure. I think I'm thinking through Russell's comment here as well, which is, you know, there might be some version of this where I can trick you into using a version that is insecure and leaking data or something like that. I don't know.
Yeah, I mean, that's what I assume the secure tag is here for, is to basically ensure ordering, like that this is non-reorderable within the query, or you can't take parts of it out and put it somewhere else in your query because that potentially could leak information. So that's why we want to be able to label something as secure.
Yeah, the secure property is letting the engine know that this is something that should be treated in the manner that you're talking about here. I'm concerned that if we attach the secure property to a signature or a version or something like that, then we're basically creating situations in which you can accidentally leak and have a function that should have been secure but is not, right? So if I can go list the versions of this function and see, aha, this is marked insecure 3 versions back, call that version of the function, then I can get it to leak things. And because versions, we don't really want to be able to either go back and edit the versions, right? Because we're saying like versions roll forward, we're going to create v2 on top of v1 for any changes. I don't think that, that would just create a situation where I go, oh, I forgot to mark v1 secure. So I go back and I do a v2 of it that is secure, but then I've left the definition out in the open because some engines might say, hey, you can't see v2 because that's secure, but you can see v1, even though there's no difference between the two.
So
I think
another
I'm worrying about it from the other angle where, what if, again, engines have a representation that I'm an engine and I see one representation is secure and one is not. Which one do I choose? Or like, am I happy with having multiple representations with different security levels? And I feel like that also feels scary. And it's probably better to just say like the entire thing has to be secure, regardless of how it's represented.
That's a good point. Yes.
Like that,
Yeah, we
the
shouldn't do
intent
this
is for the
on
engine,
this
regardless of
representation.
anything else, right?
Yeah. That
But
does.
I want to double tap on what Ryan said about the go back to the, is the engine able to go back to the version? I assume not. I mean, version here mainly, it's not like snapshots. Version here is mainly for owner of the UDFs who want to roll back. But engine as UDF consumer, do we allow engine to go back to this one of the history version?
We don't specify that because all we're saying is that this is the history. So I have arguments for and against it. The argument against it is, why would you ever need that, right? Like, you should be using the latest copy of your UDF, and you like generally should not care how that has changed over time. On the other hand, you can look at things like GitHub Actions, where like you don't necessarily know that the thing that you're calling behaves the same way now. So you might decide to pin at a particular version in order to guarantee that this continues working until a human updates it. And I don't think that we want, as a library, to have an opinion about whether a engine says, I don't support, foo at 3 versus foo. Like, I could see an argument for engines wanting to do that, and I am fine either way. We just expose data to those engines, and they decide what their semantics are.
I would rather we don't expose it, just because I feel like that's yet another set of APIs the engines all have to have. Because now I have to have like select view as of something with UDFs. Like, I don't even know, how would I do that if I have a UDF in a view and I want to get the UDF at a specific version, but the view at a different version? Like, I don't know.
So I think that you could say something like GitHub Actions, right, where I refer to either foo or foo at some version number. However, it is only the catalog's responsibility to say, here are the UDFs that exist, here is the version history, like you engine select what you're going to use. Just like we delegate, choosing the signature, casting to fit that signature and things like that, right? We don't tell the engine which signature it should be using. We try to just provide that engine provide the information to the engine. I think that is probably where we would go here too. Sorry, Talent?
I am just concerned about the one thing, like rewinding the data cases. Like if I do the time travel, I want to know that which snapshot range has the which UDF version. Then basically the engine can determine the which version is going to be used, because even latest is changed. Let's say the BR V10, and I start doing the time travel between the snapshots, then it should show me to right result always. At least this is my understanding.
So
This is
to me, there's what is the definition and what are you able to express? If we're capturing these things in views, then it is up to the view dialect to determine, like, is foo or foo at 3 allowed? And all historical stuff, right? Like, when I ran this view at this point in time, what did I actually get? I think that is all logging, right? Like, you'll get a table version for any table you scanned. You'll get a, UDF version that says, hey, I loaded and ran this UDF. I think that is all basically lineage information that we capture from the engine level, and not, like, again, this is just an argument for exposing this stuff, logging, what you're actually using when you use it. But I would not, I don't think that we want to really overcomplicate the interface here, like Russell was saying.
I think I agree, especially, I mean, you're making me think of materialized views, and I'm like, this does potentially mean that if you have a materialized view and you somehow lose state and recompute it, you can get completely different values.
Yes.
But I think that's life in this world.
But it is also achievable. That's why I'm saying that, whenever I update my function, it can update also, the snapshot ID with that. Then I know it, then for materialized view, if I recompute, there will not be any issue.
I think the problem, I mean, maybe, and maybe this is a good argument for a engine allowing you to choose the version of a UDF that you're using. I would be pretty concerned about that, because what happens when we automatically age off that version because it's no longer there? Right? Like, there are a lot of these decisions that have implications elsewhere, and we also can't necessarily identify and invalidate things like that unless we go back to the materialized view stuff and say, okay, you need to also keep track of the UDF versions that you're using. I don't know.
That's
Yeah.
why I'm saying that, this is easy to track actually. If I put the snapshot ID, commit snapshot ID on the UDF side, then we just need to write a statement like, if you want to have reliable data, then you have to keep sync with your, your snapshot versions and the UDF versions. Then the responsibility is not on our side. And if engine doesn't want to use that, they can discard that information. But at least we should have some information in UDF side, whoever wants to use it.
Yeah. We do have that information. It's the version.
Yeah, I mean, the engine gets an API call from the catalog, and they can do something with that, but they can't rely on it in the future because it possibly may not exist. I think this is similar to, like, the way we think about encryption. Like, you're given a set of keys that can open a file, but there's no guarantee those keys will work in the future because we may rotate or whatever. Like, that's kind of one of the features that we want here, is that the ability that you can kind of erase history that is not secure or has the wrong answer or something, so no one can use it.
We can write that statement on the spec definition, right? We can directly say that, hey, this is not guaranteed.
What isn't guaranteed? That versions exist?
Yes.
Yeah. I think that will be clear, because we'll probably have properties like, num versions to keep and stuff like that, like we have in the view spec.
Where we are keeping the commit ID, then inside of the version, are we going to keep that latest commit ID for table or table version and this?
So a UDF is independent of uses of a UDF in general, right? We don't update a UDF based on how it's being called. So if we derive table data using a specific version of a UDF, then that's where I think you have lineage information. that bundles up for a particular, merge statement, say, what view definitions were used, what table versions were used, what UDF versions were used, so that you can, debug and reconstruct things, but it doesn't affect the objects themselves. A materialized view may choose to store those things in order to invalidate its state. And that's what we have for materialized views today. So a materialized view says, I was last computed with this version of the view. And so we can invalidate. If the view changes, then we need to invalidate that state. I think it is a open question whether you want to do the same thing with UDFs. And I think you would, for some UDFs, want to do it, and for other UDFs, not want to do it.
Yeah, keeping the information in the materialized view makes sense to me also too, because this is the materialized view responsibility.
Well, it's the responsibility of whoever runs that view. So it would be in the table materialization of the view that you keep track of these things.
Sorry, I'm just writing about how I'm thinking about if I have a materialized view that's also built on views, I'm basically in the same boat, right? Because like if a view that my materialized view relies on changes, I have to know that that changed because I now know I can't do an incremental refresh regardless of what else I know about this view. Same thing with the UDF. If my UDF version changes, I'm no longer guaranteed that I can do an incremental refresh from my last materialized view state. So I probably do need to record that last version I used, if only for invalidation purposes.
Well, and then the incrementalization, like that allows you at the time you're incrementally updating the materialized views table to look at your settings and what you will tolerate. Sometimes you will tolerate a certain amount of staleness, right? So like staleness guarantees at that point where you're saying, can I use this table of data? You'll check your staleness guarantees and say, you know what? I refreshed this in the last hour. I'm good with it. You may also have something that says, assume UDFs do the same thing. And I think that is reasonable and valid. You might have a mode where you say track all UDF versions, and if the overload is not the version that I expected, get rid of it.
Yeah, that makes sense to me because I'm considering I put an ML model or something in my UDF here. So like a change of the UDF actually means I'm changing the whole model and I want to change the materialized view completely or something like that. So in that case, you want to trigger on for U version changing. I don't know. Just thinking.
Yeah, but so I may also have something like at Netflix, we had this, we basically had user agents from devices, right? And we had this function that parses user agents. Like it'll give me a tuple of information from this, so I know like, oh, this was a Samsung TV or whatever. In that case, we updated that UDF to parse versions quite often. And we didn't want any like newly identified devices to completely invalidate all of the data that we've produced based on that UDF. Now, maybe we figure out that this is a property of the UDF itself, like do changes to this UDF invalidate things?
Feels like a view property.
It feels more like a view thing to me, but we might want to think about that in the future.
It feels like a definition of something the engine needs to know about how the view is computed, not about the because like even the example you give, if that was used as, I don't know, something for hashing or something, it might be very, I don't know. I'm trying to think of an example where that's input to something else. So even the fact that it has expanded output has now changed everything about the table. So I feel like that's in the view, not in the UDF itself.
Yeah, geolocation IP, right? This is the case. Like that IP today may translate like Santa Clara, and tomorrow can translate Texas.
But
Yeah.
it also depends on, I think, the decisions you're making when you're running the view, because it's just like staleness. Like what amount of incorrect data am I willing to tolerate for being able to have a very fast result, right? If I'm willing to ignore the tail, then that's my staleness. If I'm willing to say, like, you know what, my user agent parsing may not have produced data for some rows, but that doesn't affect me right now. You know, and maybe then, like, every month you recompute the entire state of that table. But for now, you don't really want to do that. Or there's also a use case where maybe your churn in data, like, just makes it so that, every 7 days you kick that data out of the table anyway, so you don't want to just go back and recompute.
I think we've digressed a little bit.
The only other thing here, so I think I'm good with this, and if we move forward with this, I'm totally happy. Is there a easier way to model this relationship between overloads or definitions and versions, which is, do we want to like denormalize this so that we're not copying all of the overloads and all of the representations for those overloads every time we roll a new version? Because we could have a version has a list of definition IDs or overload IDs. Those overloads have their representations and their signatures. Sorry.
Yeah, I think we can. Yeah, if we give each overloads their own version, maybe that's something we can concatenate them by a global version, which is a list of the overloads version.
And I would say just that overload version is probably an ID, because I don't think that we want to say like a compound key overload, or sorry, signature X version 2, or something like that. But we should give that a little bit of thought, I think, in order to try and see, because all of this is representation in JSON that we can totally hide from the users, right? So a user comes and says, give me the latest version. They get the signatures that are possible at that version, and you move on. So this is something that would be entirely hidden, but is there a reasonable way for us to represent this that just doesn't have as much amplification when you make a small change?
I was just thinking, if we do the mapping of signature ID to overload, or I want to call them implementation, but if we do that, then each version is just or definition is just a list of those pairs, so you don't even have to look up from the implementation what signature it is, because I think we currently have that reverse lookup. But this way you just have it in the version string, and I don't think that's that huge because you're just storing 2 integers, just pairs of 2 integers. So it'd be like signature 1 goes to definition 2 in this version. Signature 2 goes to definition 5 in this version. Signature 3 goes to definition 7. And that's the only thing you care about when you are beginning your parsing is what is your current version state, the mapping between these things.
Yeah, I was thinking something very similar, where I just have a table of versions, or sorry, a table of definitions, and version 1 might have definitions 1 and 2 for 2 overloads, and then those have signatures. So I load it in version 1. I have 2 definitions. They each have a different signature. Move on. If I add a definition or a new signature, I create V2, and that has definitions 1, 2, and 3. you know, like it's the same thing at the end of the day.
Yeah.
However we want to represent
yeah.
that could be good.
I think it's very similar. We don't even need the two integer for the one overloads. We just need an overload because each overloads will point to one version of the signature. So that just need the overload version, a list of the overload version, which is like 3, 5, 6, something like that. Then we get a new global version, which is kind of V2 of that particular UDF. And the V3, we change one small number by adding new overloads, or update new overloads, or something like that.
And this also gets us out of updated at version, because if the definition of a version is just these 3 IDs, and then the next one is these 3 IDs, and that you can basically go and reverse all of that.
Yeah, I think my only suggestion is I just wanted to get signature ID out of overload if I could, just to, I don't know. I feel like it's weird that you don't know what the overload is talking about until you open it up. I don't know. That's just like a personal thing, though.
So I think that could be handled very easily by the API, because each overload is going to have, like, you just, you know, figure out what it is. I would prefer to keep it in the definition because it is inextricably tied to the definition. In other words, like if we were to say I have one version of this UDF, right, and it has 2 overloads, I could have, you know, overload 1 with signature 1, overload 2 with signature 2. But I can't mix and match those. I couldn't say overload 1 with signature 2. And so that seems like a modeling error to me that we can take care of by saying, like, an overload has one and only one signature, and it cannot be changed.
Yeah, I mean, I'm thinking of it. Maybe this is more from like my human readable thing. If I'm looking at my versions, I want to know exactly. This is as a human, not as like a machine. I could easily track between versions what changed without having to know which overload talked about which thing. But that's like a human readable comment, and maybe not as important from the actual modeling perspective.
Yeah, I think we could hide all. We will almost certainly hide all of this through
Yeah.
APIs.
I just am always looking at those raw files.
We almost out of time. Thanks, everyone. Yeah, it's great to see you. And yeah, see you next time.
Thanks a lot. I think we made a lot of progress. See you guys.
See you.
Thanks. Bye.